Did you know that the command line can actually be used for data science? I mean, not real data science, but in many times when you find yourself opening an Excel spreadsheet to do some stuff, this is taking some time, or when you want to run some Python script to actually run some operations, this may take you some time. Just think of it. You just open the command line, type something on your CSV file, and you get results immediately. This is very fast from my experience. So everything actually has its place. The Python scripts have its place, Java code has its place, Scala code has its place, R Studio and R languages, which are excellent, and Excel, of course. They all have their place. And recently you also have the Jupyter Notebook. But I think it's going to be very useful for you to know the basic data science command line that you can actually run. So let's start with the pipe symbol. The pipe symbol is worth mentioning in advance because almost all the commands we're going to use are using piped. And the pipe symbol, the straight line, the straight vertical line, is used in so many times, and this will pipe the output of one command into the input of another command. So we begin with the simple pipe. The next command is grep. Grep is doing a text matching. Grep is very fast way to search for a particular piece of text in a large number of files. I do this actually many times. Think about it. You need to search something in a CSV. So in Excel, you either do Control F, or in Jupyter, you write something that finds it. These things take a few seconds for you to think about, to run it. Machine becomes slow. In the command line, you just hit it and it runs. So let's say you have a CSV. Let's say this CSV is like the set of words in Shakespeare recent book that he recently released a few hundred years ago, and it's like a word and its count. So to grep for a specific word like let's say Hamlet, so you only run grep, then the word Hamlet, and then the file name shakespeare.csv. So grep Hamlet shakespeare.csv would filter out and show you only the lines having the word Hamlet. Now let's say that you want to use a regular expression in grep. So the option to use it is and to use the regular expression, you simply do grep -o, and then in quotes your regular expression, and then the file. So you do grep -o, in quotes your regular expression, and then shakespeare.csv. Okay, grep -o, regular expression, in quotes, shakespeare.csv. This will filter based on your grep. So we learned grep, we learned pipe, and now on to sed. Sed is a tool for search replace. It's a command line for just search replace. This is also very, very useful. You just use sed -i, and then in a single quote, s, which stands for search, s/ what you search for, let's say Hamlet, s/Hamlet, /William, this is what we want to replace with, /G, global. Another single quote and the star. And this means replace all instances of Hamlet with William. And if we provided a star, it will do this in all files in current directory. See how fast we can do this. Sed -i, s/Hamlet /William /G star will replace Hamlet with William in all files in current directory. Super useful, super fast. And you could also use regular expressions inside sed to perform some complex matches and substitutions. And you could do this also with back references and advanced regular expression. So we could like echo something. You could use the command echo, print something, pipe it into sed, and then instead do the regular expression. In order to provide it with extended regular expression, we do sed minus uppercase E. So echo Hamlet told William, this is the input sentence, pipe sed minus E and some regular expression, but again, you put again the S for the search pattern. Now, the relation of this to data science is that in many times in data science, the text that you receive is not in the format that you actually want it. Let's say it's surrounded by quotes and you want to remove the quotes, or it's separated by comma and you want to replace it by tab. So you can just use sed for it. I mean, just do cat, C-A-T, the command to print your Shakespeare.csv, pipe it to sed, and instead do s slash whatever you want, like quotes slash nothing slash g, and to replace all the quotes with nothing. So with a single command, cut your file.csv, pipe to sed s what you search for, and then slash what you replace with slash g, and boom, you replaced all the items in your CSV file. The next command is like a Swiss Army knife. It's a AWK. It's almost a little programming language. And if you have a CSV that contains some columns and you want to extract one column out of it, you can just use AWK. With AWK, you provide it the delimiter, and then you use $1, $2, $3 in order to get columns 1, 2, 3. So I just do, let's say I do cut Shakespeare.txt and I pipe it into AWK. I do -f because I want to say that my separator is comma, so -f with no space, single quote, comma, and then in another comma, I do open curly braces, and then I can do print $1. Close the curly braces, close the single quotes, and I will just print the first column. So again, cut Shakespeare.txt in order to print the whole file, then pipe it into AWK, and in the AWK I use the minus big letter uppercase F and my separator, and then I do print $1 in order to print the first column. Next command is sort. Let's say you are giving some items in a CSV or a single column and you want to sort them. There is a prerequisite to the sort, and we'll discuss it very soon, but you can just do cut Shakespeare.txt and then pipe to sort, and it will sort it simply lexicographically. And if you want to sort it by numbers, you just pass sort, the minus and flag. So you can do cut Shakespeare.txt, pipe sort -n, and this will sort it by numbers. If you want to reverse sorting from the last value to the first value, you just pass, you guessed it, -r for reverse. So cut Shakespeare.txt, pipe into sort -r. The next command is com. This is used in order to do union, intersections, and complements. You basically use, let's say, you use com and then you give it, what do I want? I want only from the left side, I want only from the right side, or I want the intersection. So I can do 1, 2, and 3. You pass 1, 2, and 3. 1 for the left side and 3 for the right side. So I can do com -1, 2. Okay, so I want only from the left or only from the right. And then I pass in 2 text files. 2 text files to choose from the left and not in the right, and the right and not in the left. Okay, so let's say I have a set of email addresses in 2 files, then I can do com-12 to get only the items from the left, which are not at the right. Very fast, very convenient for you to use. The next command is unique. UNIQ. What is unique? The unique is helping us in order to answer a question about uniqueness. How uniqueness is our dataset. Let's say we want only to output the duplicated items, but once. But if you want to get them only once, then you need to first sort them. So what I usually do is I cut the text file, I pass it to AWK in order to get a specific column, then pipe into sort, and then unique. Because if you do unique without sorts, you can get a duplicated item. So we first pass it to the sort. Okay, and if you want to get the count of the items after the sorting, then you can use unique -c, which will count how many duplicated items you have for each specific item. And the next command is tr. tr stands for either remove or replace individual characters. So let's say I want to delete a specific character like a new line or whatever. I just do tr-d for delete, and then in quotes the character that I want to delete. Head is very useful. Head means given a file, I want to print only the head of the file, and you can specify a number. So to combine all the above commands, let's say I do cut Shakespeare.csv, will print it, then pipe it into AWK-F, comma, will separate it by comma. In the AWK, I also pass print $1 in order to print column number 1, then pipe sort, which means sort all the values lexicographically, then pipe unique -c, print each item and also its count, then sort -n -r means sort -n means sort by number, and then in the reverse order, then pipe head -n -3, which would give me the topmost, this is crazy, this will give me the topmost 3 words which appear most times in column 1 after delimiting by comma. So if you want to get the topmost 3 items, you can just use it. And the same with the tail, which is another command. It's just a reverse of a head. WC. WC stands for word count. You can do WC -L, which means lines, for a specific file. So if I run WC -L Shakespeare.csv, it will provide me with the number of lines in the file. If I didn't do -L, it would count the words. Find is another great command. If I do find dot -type f, which means find all files, and then I pass it another command, which is -exec cut and brackets and WC -L. It means find all the files in the current directory and count the number of lines. Or find all the files in the current directory and then execute sed or execute something. tsort. Tsort is another crazy command which stands for topological sort. I won't get much into it, but it assumes you get 2 columns and then you need to do topological sort about it. You can read about it. The command T is a command that lets you split off stream of information into a file while simultaneously printing it to the output of the current stream. So I can print some file which prints to log and also T it into a log. Let's say I execute my script which prints to console, and then I pipe it into t.file.long. So we've seen many commands like grep, sed, sort, unique, and count. I recommend you to read about it more or send me more questions about it. But what I can tell you is that you can run all the above on the database, because most databases like Postgres and MySQL provide you with the ability to access them with the command line. So you can just run MySQL command line, run the SQL, get a result, and pass it to pipe, sort, and all those stuff. I hope you enjoyed it as I did. And I will see you in the next chapter of interesting topic from software engineering and algorithms. Thank you for listening, and I will see you next time.